Calculating the surface area of a specific field is a common challenge for a surveyor. Fields are often irregular, so it must be divided into several regular areas such as triangles and rectangles to be able to get their surface areas. The sum of these areas gives the total area of the field. Before measuring a field, one should first examine it to see its shape. Fields rarely have simple geometrical shapes. For the curved sides, it can be approximated by straight ones. The field can then be split up into triangles and rectangles, which can all be measured and used to calculate the area of the field. The objective of this fieldwork is to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. The instruments and accessories needed for this fieldwork are 2 range poles, measuring tape, markers like chalk or marking pins, and 2 plumb bobs. Area determination by base and altitude. The instructor assigns the locations of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. The chief of party divides the polygon into 3 triangles by taking into consideration that the divisions should be easily measured. Name the triangles as A1, A2, and A3. Measure the base of the first triangle chosen in the polygon using tape. Then measure the length of the altitude of the first triangle. The determination of the altitude is part of taping operation, which will be discussed by the instructor. Record the length of the base and altitude on Table 3.1 Area Determination by Base and Altitude. To get the area of the triangle, divide the product of the base and altitude to 2. Repeat steps 3 to 5 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas A1, A2, and A3. Here is the sample computation for Part A, Area Determination by Base and Altitude.
The same field described in Part A will be used for this method, but change the designations on the corners. We will be using F, G, H, I, and J instead of A, B, C, D, and E. Next, we will divide the polygon into 3 triangles. Then, we will measure any 2 sides of the first triangle chosen and record these measurements as sides A and B. For the fourth step, we will determine the included angle between sides A and B and record this on Table 3.2. To get the area of the triangle, divide the product of side A, side B, and sine of the included angle to 1/2. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3. Here is a sample computation for Part B. For this method, we get a total area of 24.75 meters squared. For this method, we will be using the same field described in part A, but do not forget to change the designations on the corners by using K, L, M, and O instead of A, B, C, D, and E, and F, G, H, I, and J. Next, we'll divide the polygon into 3 triangles. Then we'll measure all the sides of the first triangle chosen and record these measurements as sides A, B, and C on table 3.3. Determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle, substitute the values of the semi-perimeter, side A, side B, and side C to equation 4 or the Heron's formula. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3. Here's a sample computation for part C. For this method, we get a total area of 24.93 meters squared.